Let's find the area of the surface generated by rotating this curve around the y-axis. First off, because we're rotating around the y-axis, we are going to use a horizontal element at a random y. And when we're finding surface area, it's really just a point element. It's that point that's going to rotate around the y-axis and create a circumference. And the circumference there will be 2 pi times the radius. Now the radius is an x value. It's measuring horizontal. And so what we need to do is take the function and rewrite it in an equivalent form where x is isolated. So we will cube both sides, and we will divide by 3. So this gives us the function written as an x value, so it's measuring horizontally. That tells us that the circumference at that y-coordinate, that random y-coordinate, is going to be 2 pi times 1/3 y cubed. So that circumference will be 2 pi divided by 3 multiplied by y cubed. The surface area formula will be the integral of 2 pi r, that's the circumference, multiplied by ds. Now we don't have ds limits. We are rotating around the y-axis, and so what we are going to end up with is y limits. When we're finding surface area, going around the x-axis we use x limits, going around the y-axis we use y limits. And if you look at this function, if you were to plug in this x value of 1/2, you will get a y value of 0. And if you plug in this x value of 8/3, you will get a y value of 2. So our y limits are going to be 0 and 2. And then the 2 pi r is going to be 2 pi divided by 3 times y cubed. Now we have to figure out ds. So ds is going to be the square root of 1 plus the derivative squared. And the derivative in this case is the derivative of x with respect to y. Bring down the 3 and subtract 1. So there is the derivative of x with respect to y. So in here, we're going to get 1 plus y to the 4th. We are going to square x prime, and then we will have a dy on the outside. So there is our substitution for ds. So ds will be the square root of 1 plus y to the 4th times dy. And we have y limits of 0 and 2. Now the technique of integration here will be substitution. We are going to substitute u as 1 plus y to the 4th. Most of the time with substitution, we're going to let u be what's inside a square root, what's in the exponent position, what's in the angle position. So when we take this derivative, we get 4y cubed, and we will have a dy on the right-hand side. And if we isolate the y cubed dy, and I'm thinking of that because I see a y cubed dy right there. So if we come down here and isolate y cubed dy, we can do a substitution. So we will have du over 4 is equal to y cubed dy. So let's see. We're going to factor these constants out to the front. So 2 pi over 3. Then we have our integral. And the y cubed dy becomes du over 4. So let's go ahead and put the du over 4 right here. And then the square root of 1 plus y to the 4th, well, that becomes the square root of u. And that's everything. Now the limits of integration are now u limits. And so the u limits are found with this equation right there. So we need to take the y value of 0, plug it in there, and get a corresponding u value of 1. we will take the y value of 2, plug it in there, and get a corresponding u value of 17. Let's go ahead and factor the division by 4 to the front. So we will end up with pi divided by a factor of 2 cancels. We'll end up with 2 times 3, which is 6. Let's do our integration. U to the 1/2, we add 1 to the exponent. Dividing by the new exponent gives a multiplication of 2/3. Our limits of integration are 1 and 17. This will give us pi divided by 9. Canceling out a 2. And then we will have 17 to the 3/2 minus 1 to the 3/2. Well, 1 to the 3/2 is just 1. And typically in this book we do our simplification of the 3/2 power as follows. We'll write that as 17 root 17 minus 1.